We've been talking about rates, ratios, really even fractions for a little while now, and talking about reducing them. Do you remember how to reduce a fraction? Let's roll through that. If you have a fraction with a numerator and a denominator that have a common factor, all you have to do is eliminate the factor. Okay, let's start with 9 over 120. How do we reduce this fraction? Well, let's start with our factors. The factors of 9 are 9 is 3 times 3. What's the factors of 120? They'll be an awful lot like the factors of 12. Watch. Look at that. 120 is 12 times 10. Now what are our factors of 12 and 10? Whoa. Okay, so 12 factors into 2 and 6, but 6 isn't done. We'll come back to that. 10 factors into 2 and 5. Why are we factoring into prime numbers? Because prime numbers can't be broken down any further. There we go. 6 factors into 2 and 3. So prime factorization of 9 is 3 times 3. Prime factorization of 120 is 2 times 2 times 2 times 3 times 5. There we are. We've got all our factors circled. Do we have any for 120 that we also have for 9? You bet. I canceled out one of those 3's to cancel out the other 3 over here. That means that we have canceled out all the common factors between 9 and 120. We just have to put 120 back together without its 3. All right, so if you put 120 back together without a 3, or basically divide 9 by 3 and 120 by 3, we can say that 9 over 120 reduces to 3 over 40. That's reducing the fraction. We haven't found the unit rate. To find the unit rate, we would divide 3 by 40 and 40 by 40. That's not what we're doing right now. Instead, let's look at this and find some more reducible fractions. All right, so here's 3 more to try. 60 over 144, 8 over 12, and 15 over 45. 60 factors into 2 times 3 and 2 times 5 because 6 times 10 is 60. 144 is the classic 12 times 12. 12, though, each time will factor into 2 times 2 times 3. Whoa, hey, look, did you see that? I factored the 12s differently to show that you don't always have to factor exactly the same as somebody else. You'll still get the right answer. 12 is 2 times 2 times 3, or 3 times 2 times 2. We know that that's the same thing. But now we need to do something to reduce the fraction. Let's do that. Let's eliminate our common factors. Cha-ching! I've got a 2, a 3, and a 2 over here. I've got a 2 and a 2 and a 3 over here. Let's get rid of those. Now, I've still got a 3, a 2, and a 2, and a 5. That must be what we reduced to, because there's nothing on the other part that we can pair with the 5 to get rid of the 5. Let's put it back together. Cool! 5/12. That's now fully reduced or completely simplified. And that is our final answer. Okay, it's not our final answer. We're going to do the other 2. 8 factors into 2 times 2 times 2. There you have it, folks. 8 factors into 2 times 2 times 2, while 12 factors into 2 times 2 times 3. We can get rid of our common factors. What's left on the 8 side? Just the 2. What's left on the 12 side? Just a 3. 8/12 must be equal to, you guessed it, 2/3. Anybody want to guess on this last one? I bet you can. 15 factors into 5 and 3. 45 factors into 5 and 9. What about that 9, though? It's not prime. 9 factors into 3 times 3, which means 3 times 3 times 5 is 45. But 5 times 3 is 15. common factors? Let's do this. There's only one factor that's not common. That's the 3 with the 45. That means we can get rid of everything but that 3. Does that mean that our answer is just 3? No, because 3 was the denominator. We've still got a numerator of 1. That's just how it works. Starling, I don't like doing prime factorization. Cool, kid. You don't have to. You just have to make sure you divide the top and the bottom by something that they will both divide out evenly to be able to reduce the fraction. 18 over 27's kind of not nice looking, but if you just divide both numbers by 9, that's pretty easy. We know 27 divided by 9 is 3, and 9 goes into 18 2 times. So, what about all that prime factorization stuff? We just didn't do it. Is it great? Yeah, it's great to do prime factorization because the prime factorization that we were doing, like we learned earlier in first semester, the prime factorization is a great way to give us all the factors of a number broken down to their smallest components. That gave us the tiny factors that we could eliminate. And that meant we could get down to the nuts and bolts. However, what about this? 96 over 16. That's not nice, Mr. Starling. But it is something we can totally do. Do we want to divide 96 by 16? Maybe not. What can we divide 16 by? How about 8 and 2? So, as long as we divided 16 by 8 and 2, how about we divide 96 by, I don't know, just getting wild here, maybe an 8? Wild and crazy, that's what that is. If you divide 96 by 8, you get 12. That means we've got factors of 8 that we can eliminate. That means this is 12 over 2. That's not finished. 12 over 2 is 6 over 1. And that's a unit rate. How do we know what to divide by? We can just sit and plug and chug, trying out different numbers on the calculator. That could take a while. There are some shortcuts, and also there's just simply the practice of having more math experience and saying, I know that 13 times 3 is 39, but that 13 times 5 is 65. Who even remembers 13 times tables? Not many of us. Why? Because most folks don't bother to learn them. We've got calculators. Still, here's some shortcut rules. Here's some examples. 27, we know, is 9 times 3. So 27, 2 plus 7 equals 9. And 27 divided by 9 is 3. 162 is not something we memorized. 1 plus 6 is 7, and 7 plus 2 is 9. 162 divides by 9 and gives us 18. Clean. This 4,563 number. 4 plus 5 is 9. 9 plus 6 is 15. 15 plus 3 is 18. What do we do with that? That's not 9. 18 is 1 plus 8. It's not how you get 18, but you add the digits and it comes out to 9. That, of course, means that 4,563 will divide evenly by 9, and if we're going to divide it out by 9, let's see what it is. It's 507. So, in the end, what do you want to do to find your factors? Whatever it takes. Do you have to find factors? No. Don't steal somebody else's factors. Do your own work. Practice reducing fractions. That's today's assignment. And it's today's assignment because reducing fractions is also reducing ratios.